Hello everyone, I am Sudhu Singh HJ. Here myself and team members are to present to solution for the garbage classification. Proper waste management is the crucial for the reducing the pollution and promoting the recycling. Manually sorting garbage is inefficient and the error prone, so we explored to using the deep learning to automate this process for our task of the classifying the various type of the garbage such as the cardboard, plastic and the glasses. So we chose the DensNet 1 to 1. Its efficient architecture help in accurately recognition the different waste materials, making it a strong choice for the improving the waste store in the automation. DensNet 1 to 1 is the design to the maximize the information flow between the layers by connecting each layer to every other layers in feed-forward fashion. So this helps to mitigating issues like Venetian gradients, ensure the better feature propagation, and the improves the parameter efficiency. So first I mount the Google Drive data and unzip the data. So and the first, I loaded the images using the image data generator and applied the augmentations like the random rotation, heist shifting with shiftings, and the increase the diversity of the training samples and reducing the overfitting. So this is code for the loading and training the images in and the validation images. So this is the DensNet 1 to 1 architecture pretend on the image net, and I included the top layer. So this is code for the freezing the base model, and I added the custom layers and create the model. So I compiled the model using the Adam optimizer with learning rate 0.001 and categorical cross entropy as the loss function. So after the training, DensNet 1 to 1 achieved a validation accuracy of the 94, which was higher than the other architectures like CNN and the uh, efficient Inception V3. So I plotted the some graph for the test the actual and the predicted value check, and also this is for the model summary, and also I graph the summaries like training and validation accuracy, and also the confusion metrics. So thank you.
My name is Tisila BAP. My IT number is IT21338748. My part of the project is to develop a model using ResNet architecture to classify garbages. For that, I have used Google Colab. And first of all, I have uploaded my dataset into my Google Drive. And here you can see I have mounted the Google Drive and set the path for the dataset. You can see in the root directory, the loaded dataset is here. And after that, I have import all the necessary libraries. Then I have set a input path, input size, which is the default size for the ResNet architecture, and created a batch size for 32. After that, I have used image generator function to augment the images and the pre-processing task. I have set 20% for validation as well. After that, I have loaded the ResNet 50 model, which is most stable ResNet model, this ResNet 50. And I have add some custom layers for that model. One of a global average pooling and the fully connected layer with rel evacuation function, and a dropout layers as well to mitigate the overfitting problem. Uh, then I have used the output layer with softmax activation function. The reason for use softmax is output is contains six classes. After that, in creating the model, I have compiled the model, and this is the model summary. You can see here. After that, I have initially trained the model for 10 epochs. After the training, you can see the output of the training accuracy as well. After the evaluation of the model, it contained 37% accuracy with the test as the test accuracy. After the initial training, I have unfreeze all the layers of the model for fine tuning, and here I have used the Adam optimizer and with a very low learning rate for better accuracy, and I have used the categorical cross entropy as the loss function. And after the optimization, I have rerun the model with additional 20 pops. And after the fine tuning, you can see I have gained better training accuracy rather than previous one. After the evaluation, you can see test accuracy got 99%. Uh, this is the final accuracy of the model. And after that, I have plot some figures graph. First one is the validation accuracy versus validation loss. You can see here. And the other one is weight and bias distribution over each epochs. You can see like this for all the epochs. And the other one is the accuracy versus epochs for the initial training and the accuracy versus epochs for the after the fine tuning. You can see. As the final, I have generated the confusion matrix for the above result. So this is my process, and this is my task I have done in the project. And thank you.
I'm basing Hayu. My IT number is 21333552. My part is training the model, Inception V3 model. Inception V3 is a neural network designed by Google for efficient image classification using Inception modules to capture multi-scale features pre-trained on ImageNet. It's widely used for transfer learning in tasks like garbage sorting. This section mount Google Drive to access my dataset and install TensorFlow uh, for building the deep learning model. Uh, this command checks if a GPU is available for transfer faster training. Here, the pre-trained Inception V3 model is loaded and modified with custom layers, global average pooling 2D, reduce feature map from pre-trained model, uh, and dropout regularization to prevent overfitting. Dense layer, this is the output layer with six classes using softmax activation. All necessary libraries are important, including Inception V3 for transfer learning and Keras modules for creating layers and training the model. Libraries are visualization and evaluation like Matplotlib and Seaborn are also important. Data augmentation helps improve model generalization by augmenting images during training. Callback callback. These are mechanisms to control training, early stopping, prevent overfitting. This one reduce the learning rate and model checkpoint saves the best performing model. After training the model, evaluate on validation set, confusion metrics and classification reports show performance on of the model for each class. This code extract converts the model's final validation loss and accuracy into percentage, showing 2.53 loss and 96.77 accuracy. It indicates strong model performance on the validation data with minimal loss. These plots show the training and validation accuracy and loss across the epoch, helping visualize the model's learning progress. Thank you.
Hello, my name is Priscilla CSCTS. My registration number is IT 21219702. So I have given a solution training a module using CNN, which is convolutional neural network. For that, I have firstly download my dataset and upload it to a Google Drive and mount the Google Drive to the Google Colab. After mounting the Google Drive, I have set the database path to the this variable database path, and after that I have installed the necessary libraries such as TensorFlow, Keras, Matplotlib, uh, and, uh, and also I have imported the necessary packages from that library. Um, and the image size is set to the width and height as 224 pixels. This code explains the data augmentation and the normalization part. Normalization is done here, and others are the variations of data augmentation. After these other data generators, from those data generators, I have found 9,087 images for the training and as well as 2,271 images for the validation. So this is I have set 3 convolutional layers to this model, and I have set dropout as 0.5 to prevent the overfitting, and the software activation function to the final layer with 6 dens because there are 6 outputs, and the model is compiled with learning rate of 0.0001. So this is the summary of my model. After that, I have trained the model using 10 epochs. So after training the model, this is the model accuracy and the model loss comparing training and the validation. Final accuracy I got is 58.7. So that's it for my part. Thank you.